In this section we had a lot of definitions, and so you're going to have to make sure that you know and all of these definitions and how to use them. Some of the questions that you'll get asked will ask you to use definitions in order to explain why things are true or false. So for this first statement, we have the picture over here, and it says line AC is perpendicular to line BD. If we look, we have this box right here, and that shows that there's a right angle formed here. And if a right angle is formed there, then we know that there are perpendicular lines there. So our definition would be perpendicular lines form right angles, therefore the two lines are perpendicular. So again, the definition we would use is perpendicular lines form right angles. For the second one, we've got AEB and CEB are a linear pair. If we look again, since this is 90 right here and that's 90 right here, these two angles together form, they end up being 180 degrees. So by the definition of a linear pairs are supplementary. We can state that this is a true statement as well. For the last one, we've got ray EA and ray EB are opposite rays. Ray EA goes off to the left, ray EB goes up. So in this case, in order for EA and EB to be opposite rays, E would have to be in between A and B, and in this case it's not, so therefore EA and EB are not opposite rays, so that one would be false. We'll go over what the book says as well. The first one is true because of the right angle symbol indicates the lines intersect to form a right angle, so they're perpendicular. For the second one, it says that the non-common sides of adjacent angles are opposite rays, so the angles form a linear pair. You could state that it's just the definition of a linear pair, or that linear pairs are supplementary. And for the last one, it's false again because E does not lie on the same line as A and B, or that E is not between A and B, so they're not opposite rays. For this next one, we have angle JMF and angle FMG are supplementary. Let's take a look at those two angles real quick. We've got FMJ right here, and we've got, JMF and FMG. So if we look at those two angles, these two angles are supplementary because they form a linear pair. So in this case we would say the statement is true because linear pairs of angles are supplementary. Again, the definition of linear pairs. And we want to know if point M is the midpoint of FH. In order for that to be true, we would need to have a tick mark there and a tick mark there. Since those tick marks are not there, we do not know if M is the midpoint of FH, so we would say it's false because we don't have enough information. So it's false, we don't know if those are equal, therefore we don't know if M is a midpoint. And let's take a look again. We've got JMF and HMG are vertical angles. The first angle, JMF, is right here, and HMG is here. And those two are vertical angles by the definition of vertical angles, and we would know that these two angles would be congruent as well. But the definition of a vertical angle tells us that those two angles are vertical angles. And again, the definition is intersecting lines form two pairs of vertical angles. Now we've got FH is perpendicular to JG. In this case, we've got FH right here. We've got JG right here. There's no box here to tell us that those are perpendicular, so we can't assume they're perpendicular even if they looked perpendicular. So in this case we would say we don't know if any right angles are formed by these two lines, so therefore this would be a false statement. And that's basically what all those words say. We can't say that. It may be true, but we don't know if it's true. And that's it for this one. Thank you.